So like I showed you in the warm-up, we had a problem. Oops. X squared minus 8x plus 16 equals 25. And I told you to kind of like note that x squared minus 8x plus 16 is equal to x minus 4 quantity squared. In other words, x squared minus 8x plus 16 is a perfect square in the same way that 9 is a perfect square because it's 3 times 3, right? And 16 is a perfect square because it's 4 times 4. X squared minus 8x plus 16, that polynomial as a, one whole polynomial there, it's a perfect square of the binomial x minus 4, right? You multiply x minus 4 by itself, you get that. So what this allows us to do is it kind of provides a different strategy. Okay, it provides an additional strategy here of solving these quadratic equations, and it actually kind of allows us to use factoring, not needing to equal 0, right? So you can factor this thing, and it doesn't have to be equal to 0. And so again, like I'll just show you. We'll replace, that left-hand side with this. Okay, we can square root, right? Because we have that whole quantity is squared, so we can undo it by square rooting, and we square root the other side. We get the x minus 4 equals plus or minus 5, which means x equals 4 plus 5, or the 4 minus 5, which in other words is 9 or negative 1. Okay? So, this is already a perfect square, so it was nicely set up for us to go ahead and solve. But what happens if we don't have a perfect square? Right? What happens if we don't have a perfect square? So, I'll write that out as a question. What happens if the quadratic doesn't factor, right? So that might be a case. Or doesn't factor to a perfect square. Okay, so that's kind of the big question, right? This strategy that I showed you here only really works for this special kind of polynomials, special quadratics that factor into perfect squares. So what happens if it doesn't factor at all, or if it doesn't factor into a perfect square? Well, the answer is, okay, we make it work. Okay, and how are we going to do that? Well, I'll show you here. So, we'll start with a basic idea. Find the value of c that makes a perfect square. Okay, so that's this. We'll do an example here. Okay, so we'll start with x squared plus 16x plus c. Okay, and we want to be able to factor this thing. Okay, or you can also think of this as like, x squared plus 16x plus blank. And we're going to like fill in this blank here. Okay, we want to fill in the blank so that this thing factors to a perfect square. So let's pretend here, okay, that we already have our answer. Okay, we already have the answer for c, we already know what it is, and we're just going to go ahead and factor this thing like it's perfect square. So in order to factor this, right, we'll need an x here and an x here. Because the x times the x make the x squared. All right. Furthermore, right, these two numbers over here, these two numbers, they will multiply, and give us what part of our quadratic up here? C, right? But we don't know what c is yet, so we're going to have to hold off on that, but that is going to be true. These two numbers will also do something else, though, right? This number right here will multiply with this x, and this number right here will multiply with this x, and together they will have to add up to make what? 16, the middle term, right? So again, this mystery number times x plus this mystery number times x, together we'll have to combine together to give us that 16. Okay? So at least you have a goal there. Remember also, we're trying to make a perfect square. So these two numbers will not only have to add to make 16, but what else will have to be true about these two numbers? If we're trying to make a perfect square here, they will need to be what?
Same.
The same. Exactly right. We need the same number here. Because for a perfect square, you need the exact same two things that you're multiplying together. So, what two numbers are the same, and then add to make 16? So 8 and 8 add to make 16. Okay. I did hear a 4 out there. But 4 multiplies by itself to make 16. We're adding right now. Okay? So, there it is. So in other words, x plus 8 squared. That's going to be our goal here. So then C, we can now kind of work backwards from what we know we need. Right? We can work backwards here to see, okay, well then what does that C value end up being? I heard it. 64. Yeah, 64. Okay, 64. So C, in this case, is 64. This is kind of like a baby step towards our ultimate goal here. So this is not like what we're going to be doing all class long today. But well, we will be doing this, but this is like part of what we're doing, right? Okay, this is just kind of get us introducing the idea. We started with something that was not a perfect square, right? This is not a perfect square necessarily. We don't know what C is. We wanted to find a value for C that would guarantee this polynomial is a perfect square. Okay, it's quadratic here. So again, what do? We factored. We pretend like we could factor it. We have the x and the x. We figured out these two numbers because they have to be the same, but we also know from our foiling and stuff like that they have to add to 16. So that makes this 8 and 8. And if those are 8, that means then our C value would have to be 64. And that gives us the answer that guaranteed that perfect square. So we took something that was not a perfect square. We figured out what value here would make it a perfect square, and then we created that perfect square. All right. Questions on any of that? So I'm going to give you guys something to try here. Okay, you guys try one. So same directions. All right, same directions. Let's have you do. Again, or if it helps, you can think of it as x squared minus 22x plus blank. And I'll give you kind of like the. So think about how that would need to factor to create that perfect square. So go ahead and take like 30 seconds. Remember, the ultimate answer here is what is C? What do we have to add in there to make it work? Jack, you got an answer for us here? What is our value of C going to be? 121, Jack says. Okay. We agree with that? Okay. Well, so let's see here. What numbers do we need to put in here?
11.
Negative 11s, right? Negative 11s. But then when you multiply a negative 11 times a negative 11 to create this C, it'll become a positive 121.
Why would it be two negative 11s if you're supposed to... never mind.
You're okay?
Yeah.
All right. Any other questions on that? Super important. We make sure we understand this. Any questions? I can talk it through. We all okay? Yes, yes, yes. Okay, or you just don't want to ask anything? All right. So, that's the idea. This is taking something that is not a perfect square and we make it a perfect square, right? By using the two terms that we do have, okay, and then creating that perfect square. So, let's see how we're going to use this in action. Okay, so we're going to solve by completing the square. Okay, solve this equation here by completing the square. So again, when you look at this, and this is where it gets a little bit tricky for some students, right? If you just kind of like come across this problem, without us setting you up and stuff like that, and maybe even if you even read the directions, you might look at this and say, oh, I know this kind of setup. This is where we're supposed to factor this side and then set each factor equal to 0. But this thing, and that might be a strategy you could use, right? But I do ask you to do by completing the square, so that's one thing. The other thing is, does this thing factor? Can you think of two numbers that multiply to make a positive 4 but add to make negative 12? No, right? No. So this doesn't factor, okay? So this is a strategy, this complete the square strategy will allow us to solve some of these quadratics that don't factor, okay? That we run across, right? We've already, So, and then tomorrow we'll look at using the quadratic formula, which will allow us to solve any quadratic equation we come across. But, we're going to do this one first. Okay, so we're going to solve it by completing the square. So we're going to take this thing, and again, we're going to pretend like it factors. But first, you'll notice here that we already have this c value. All right? Before, we didn't have this c value. So what we'll do to kind of help ourselves set up in more like the previous problems where we did not have a c value, we're going to move this 4 over. Okay? This is not a necessary step, but it is helpful. Okay? It's not necessary, but it is helpful. So we're going to move the 4 over. Okay? And now you can see we have that missing c value, okay, in our quadratic here. We have that missing c value. And so we'll pretend like it actually factors. Okay? So down here, right, what two numbers are we going to use to make that negative 12? Negative 6 and negative 6, right? So, with that being said, right, because the negative 6x and negative 6x make it the negative 12x, then what is our c value that's missing here? 36. So we're going to add a 36. Now, that 36 came from nowhere, right? And I'm in an equation. When I add something to this side of the equation, what else do I need to do? Balance it out on the other side here. So I'm going to add the 36 on the right-hand side as well. Okay? And we'll simplify, so we get 32. Less. Okay. Now we'll rewrite x minus 6 quantity squared is equal to 32. And then how should we proceed in order to finish solving? Square root both sides. We could square it out, we could factor it and stuff like that if you wanted to go that path too. That's a little bit more work. I think it's already nice except for the square root, so we do that. But yes, you could do x minus 6 times x minus 6, bring that 32 back over, but I think you would actually end right back with what we started with here, and you would never factor it. So you want a square root from here. That's what we're going to use. That's why we started. That's why you did the square root stuff just prior to this to help bring it up, bring this up. Okay. So we get plus or minus, and then that root 32. Let's go ahead and simplify that. What perfect square can we divide 32 by?
16.
Sure, 16 is a good one, and that probably the better one. You could also say 4, but you can, there's more simplification after that. We'll do 16. That's the biggest one. So it's root 16 times root 2, which is going to be 4 root 2. So this would be plus or minus 4 square root of 2. Okay, and the final step, what do we do to both sides?
Add 6.
Add 6. So you get 6 plus or minus 4 times the square root of 2. And there's our solved quadratic equation. Okay, without requiring any, quadratic formula or anything like that. Okay. Questions on any of that? Want to try one on your own? Okay. You got it. Okay, you guys go ahead and try that one. X squared plus xx plus 4 equals 0. And just remember, to get this thing started off, move that c value over, so we'll get equals to negative 4 over there. Okay, and then fill in that blank.
It's kind of weird because we're like working forward and backward, and I'm jumping between the two steps at once. So it's like, I know. Let's see. It's like, one right here. Got it. Right here? Yeah, that looks good. Yeah. So you start with a negative 4. So you added 9 to this side. So you should add what to this side, which would then create not a 1, but now a. Okay, so that's 1%. Okay, yeah, looking good so far. So that means x plus 3 times x plus 3 would be 5. So that x plus 3 squared equals 5. You can solve it. Okay, you got that okay? Good job.
I don't know.
You are very close. So first of all, when you square root of both sides, what should you put in front of the square root? Yeah, right, an equation. So you square root both sides of the equation. You have a plus or minus 1, right?
Right.
And so then we add 3 to this, it'll be 3 plus or minus 5. So 3 plus root 5 is the answer, 3 minus root 5 is the answer. Make sense?
So I don't take
So the square root of 5, can you simplify that?
That's 2 days.
No. So equals, and then plus or minus root 5.
Yeah,
And then just finish.
Now we're last. Now we're last.
It didn't last the whole time.
Yeah, so
But now we're in a
so
deeper hole.
you subtract. That's right, so it's minus 3. It's plus 3, so subtract.
I wasn't allowed.
Yep, negative 3 plus or minus root 5. Okay.
Fresh. I wasn't
Okay.
allowed outliers.
Yeah, you feeling okay on this stuff so far? All right. All right, real quick here. Let's run through this because I have some more to show you as well. Let's go to Tessa. Tessa, so what did you add to both sides here to solve this? 9. Very good, okay. If you're not sure where that 9 came from, right, again, think about we're going to work like one step ahead here. We know that we have an x and an x. We need these two numbers to add to make 6, and they have to be the same to make a perfect square. So it's going to be plus 3 and plus 3. Excuse me. Which then means we have to have a 9 here to make this thing actually work out, okay? Since we added a 9 on this side, we're going to add a 9 over here. Since we already have that negative 4, though, so it's negative 4 plus 9 to make a 5. So we have x plus 3 squared equals 5. Square root both sides. Get x plus 3 equals plus or minus the square root of 5. Don't forget that, right? We're still in an equation here. And so you get x equals negative 3 plus or minus the square root of 5. Okay? So the two answers are negative 3 plus the square root of 5 and negative 3 minus the square root of 5. And there are our answers there. Okay. Questions on any of that? Okie dokie. Well, we're not quite done yet. Not quite done yet. But that's a very good start. If you feel like you're getting it down all right, that's a very good start. Okay. Just a few other little twists we could see. So I want to make sure we're good with that. We'll do another example here. Okay. So let's see another one. How about what's that? Why are we saying oh no? What's different about this one? Yeah, it's got a lead coefficient. Oh, man. Oh, man. Okay, well, we do have that 2 there. So we were feeling pretty good when our lead coefficient here was a 1, right? When we had, 1 x squared, right? A was 1 here. We were feeling pretty good about these, I hope, right? But now I throw this one at you, it's got a 2 in front. But what could we do to this to go make it look like one of our original ones here?
Divide everything by 2.
Yeah, exactly, right? So if you have a lead coefficient of 2, all right, divide all of your terms by 2. And of course, if I divide the left-hand side by 2, what do I do to the right-hand side? Divide by 2 as well, but that's 0 divided by 2. Who cares? So easy, okay? So yeah, we'll divide everything by 2. Divide everything by 2. Okay? There's another way to think about this too. I'll show you the alternative way as well, but I'm going to show you this way first because I think this is the most clear way to do it. So yeah, we will divide everything by 2, and so that leaves us with x squared plus 4x plus 7 equals 0. Okay? And now it's the same old thing as every other completing square problem we've done, right? We'll move that 7 over so that way we have our blank to fill in. Okay, we'll factor. Pretend like it factors. So we need 2 numbers that are the same and add to make 4. So that would be, what are these 2 numbers going to be here? They have to be the same, and they add to make that 4 there. So 2, right? So plus 2, okay, which means we were missing up here a 4, and we'll add 4 to this side as well. Okay, so you guys finish the rest. Go ahead. Okay, so hopefully you got something that looks like this. -2 plus or minus I root 3. So there's imaginary stuff, right? We should be able to do now any imaginary stuff that comes along too. You see the square root of a negative, right? It's just going to show up. It's not going to alarm you in the directions. There may be imaginary solutions, right? You should, if it comes up, you should be able to simplify it. No problemo. Okay? Or if you have problems, get it figured out before the test. Questions on any of this? So let me show you an alternative way to think about this. Another way to kind of think about completing the square. Okay. So let's see here. How much of this do I want to show? All right. An alternative way to think about completing the square, okay, is to take our problem that we have right here. Let's start from the beginning, actually. Okay. Oops, 14. Okay. So another way to think about this, besides what you guys suggested, which was to divide both sides by 2, we can factor out a 2 here. Okay. Actually, I think think I wanted to move that 14 over first. My apologies here. Let me, yeah, I'll just redo it, sorry. Let's move the 14 over first. We'll get 2x squared plus 8x, and we'll make it equals negative 14 there. Sorry, and then we'll factor up a 2. And I'll leave the blank there. Okay. So now when we go to look at this, okay, we'll still have the 2, right, because that 2 is still part of it here, but we're going to factor this quadratic. Again, pretend like it factors, right? So we have the x and the x. And it's the exact same quadratic as what we had before, right? So no surprises here. We're going to add a 2. We're going to add a 2. Right? The 2 and the 2 would make that 4x. And what number is missing here in our blank? What would this multiply out to? Yeah, we're missing a 4 still, right? So plus 4. Okay. But now when I go to balance it out over here, this 4 in this case, right, over here, this 4 that I added on both sides, the 4 was not in a set of parentheses. It was just this quadratic, right? And I'm just adding a 4 here, so I added a 4 here. But this 4 is in a set of parentheses. What value did I actually add to the left-hand side of this equation? When I brought this 4 in, what value did I actually add to this left-hand side of the equation? 8. Why?
4 times 2.
Yeah, this 4 is inside the parentheses, okay, and it has a 2 in front of it. So when I add this 4 in, that was in the 2 parentheses with the 2 out front, that's really adding a value of 8. So when I go to balance it out over here, what should I really add? 8. Okay. And you'll see that negative 14 plus 8, what do we get? Okay, we get negative. What did I mess up? Did I mess up something here? I feel like I messed up something. I'm adding 8. Negative 4 plus 8 should give us negative 6. But then that's not the same thing as what did I? Oh, I missed. No, I didn't miswrite the problem. What did I do? Oh, yeah, right. Sorry. Thank you. Right. And then we would then have 2 parentheses x plus 2 squared equals negative 6. Sorry. Okay. There we go. Right. And then like you were going to say. Right. At this point then, what would be the next step we would do to solve? Divide both sides by 2, right? And that would give us the x plus 2 squared equals negative 3. Okay? And so this is the exact same thing that we had from right up here, right? X plus 2 squared equals 3. So you know, dot, 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 we get the same answer as we would right there. Just a slightly different way of doing things, that's all. Okay? Shall we try one more of these with the a value not equal to 1? Yeah, one more? Okay. Let's do a little bit of a weirder looking one. 6x times x plus 8 equals 12. And again, we want to solve by completing the square. Okay. So, thoughts here about how we should maybe proceed to be able to complete the square? Yeah, Jordan, what do you say?
Distribute.
Yeah, exactly. Right? This is not the typical way, right? We've been seeing our problems, right? Our problems normally have them all like in standard form. We can do the same thing here. So let's go ahead and distribute. So we'll get the 6x squared plus 48x equals 12. And now you'll notice that we kind of have it nicely set up. In fact, maybe I should have just left myself some space there. Okay. So distributing there kind of sets us up pretty much, except we have one more thing here we should probably do before I actually complete the square. What's our next step we should probably take before we complete the square?
Divide by 6.
Yeah, divide everything by 6, right? We have that lead coefficient of 6. We don't want to have a lead coefficient there of 6. So let's just do the division thing. Okay, so we'll divide everything here by 6. The left-hand side by 6, the right-hand side by 6. So we'll end up with x squared plus 8x, and then our blank there equals 2. So again, it started out looking weird, but you just rewrite it so that it's in the more normal format of, the standard form there. Okay? And then we divide everything by 6 to get rid of that lead coefficient, left-hand side and the right-hand side. And now we've got to figure out what we're going to add. Okay? So again, We need two numbers that add to make 8, and they need to be the same. So yeah, 4. Which means what is missing in my blank right here? 16, right? I'll add 16 to this side as well. Okay. And then we can just simplify from here, right? Square root both sides. Plus or minus. So root 18. 18 is not a perfect square, but what perfect square divides 18? Yeah, so we'll make it 9 and 2, which makes it 3 root 2 there. So this becomes plus or minus 3 root 2. And then we'll subtract the 4 over. Voila. Okay. Excuse me. Questions on any of that? All right, we're not quite going to have one more thing I want to show you, but that was just more of a stranger looking one right there. Okay, I'm going to try and squeeze in another example or two right here at the bottom. Okay, the last thing that this now allows us to do, okay, is if you remember back when we first started this unit, right, we learned 3 different ways to graph quadratics. We had standard form, we had vertex form, we had zeros, intercept form, okay? And one thing we need to also be comfortable with is converting from standard, or between all 3 forms, basically, going from one to the other. Taking the intercept form or the vertex form into standard form is pretty easy. It just involves multiplying everything out and then rewriting a standard form, right? But converting from standard form to intercept form or standard form to vertex form was a little bit trickier. Okay, standard form to intercept form is just a matter of factoring, right? You just factor that quadratic, and that'll get you into intercept form. Okay. Vertex form, we're going to use the quadratic formula. So we're going to be able to convert now from standard to vertex form. And we're going to do that by completing the square. We weren't able to do it up to this point until we completed the square. So let me show you an example. I'm going to show you doing a 2 problem. Just because I think the first one you guys will get pretty easy. Okay, now this is a bit different, right? Because we have an equation, but there's this y over here. You can still do what we've been doing. So in other words, you can still move that 22 over here. So you can make it y minus 22 if you want to equals x squared minus 10x, and then you leave your blank. Okay, so you can still do that. Okay, and we'll still complete the square like you normally would. So again, let's pretend like this thing factors. What 2 numbers are going to go in here with x? Negative 5, right? We need 2 numbers that add negative 10, so it'll be negative 5 and negative 5. Which means what's missing from my blank right here? 25. So add a 25, and then, because I added 25 here, we'll add 25 on this side too. Which really then gives me y plus 3 here, right? And that creates... Okay. And then we're almost done, right? What's the last step I need to do here to get, this in vertex form? I have a plus 3, so we'll subtract that 3 over here and make it y equals the quantity x minus 5 squared minus 3. What is the vertex of this quadratic?
5, -3.
Yeah, 5, -3, right? The x minus 5 means we're shifting right 5. The minus 3 means we're shifting down 3. Excuse me, so it's 5, -3. Okay, so there's the vertex of our quadratic. Right? So the sides using the negative b over 2a, like I showed you guys before. Negative b over 2a gives you the x-coordinate of your vertex. You can also complete the square for your quadratic equation there, and then just get it in vertex form, where you can then just read the vertex. 5, negative 3. Okay, let me do one more here. The height of a baseball in feet is modeled by, I'll just zoom in on this. Height of baseball in feet is modeled by y equals negative 16t squared plus 96t plus 3. What is the max height? Okay. Let's do this last one here together. Let me show some of your assignments. Okay. Maximums and minimums, right? When it comes to quadratic equations like what we have right here, maximums or minimums will always be located at what special point of our quadratic? The vertex, right? If your quadratic is concave up, like a cup, right? That means we will always have a what at our vertex? What extreme value? Maximum or minimum? Minimum, right? Okay. If we are concave down, like a frown, okay, then our vertex will always be a maximum. Are we concave down here in this quadratic equation?
Yes.
How do we know?
Negative 16.
The a value here is negative 16, right? Which means we are concave down. Okay. So we should have a maximum, right? So we can at least, kind of convince ourselves, yes, we must have a maximum here. We have to figure out what it is. And we're going to do that by finding the vertex. And we're going to find the vertex by completing the square. So yes, you could use negative b over 2a here, right? That would give you the x-coordinate. You'd plug that in, or the t-coordinate, I guess. You could plug that in and get the matching, y value for the height. That would work too. What we're going to do is via completing the square. Okay? So we'll subtract this 3 over here. Okay, so subtract the 3 over, right? Now here, our a value is not 1. Okay, our a value is not 1. So what we're going to do is, we're going to deal with this, well, I'll leave it up to you guys. What would you guys like to do here to deal with this negative 16? What do you guys think, what would you do? Divide it? Yeah, all right, let's divide. So if I divide this side by negative 16, I'll get t squared. And then 96 divided by negative 16, I'll do that in my calculator here. I feel like I should know that. Oh, it's negative 6. Yeah, I should have known that. Okay, negative 6t. But of course, if we divide this right-hand side by negative 16, what else do I need to divide by negative 16?
Other side.
The left-hand side. Ooh. Okay, but let's do it. Let's just see here. So negative 1/16 y plus 3/16. Right? So we divided everything by negative 16 over here as well. Divide this side by negative 16, divide this by negative 16. Okay? Yes, it's a little yucky, but that's because, some of our numbers here were kind of large. All right, let's complete the square. So this side over here, right, is going to factor to t and t. Okay? What's missing in these blanks to make this work out? What numbers here do I need to put in? Negative 3. You got it, right? Negative 3, which means what is missing right up here? That 9, so plus 9. Okay. If I add 9 to this side, right, and I add a straight up 9 here, right? There's no there's no parentheses or anything like that. I added 9 to this side, so I'm going to add 9 over here as well. Squeeze it in. Okay. So I'll get t minus 3 squared. And then over here, I got to do some simplifications. We have to add 9 and 3/16. So 9 and 16 will be 144/16. So 144/16 plus 3/16 would be 147/16 plus negative 1/16y. Okay, I'm running out of space here, but I'll move it up to here. Okay. So again, I just added the 9 and the 3/16 there to get the 147/16. Okay. All right, let's continue with our algebra here. We want to get the y by itself, right? Vertex form, we need y equals, right? So what should we do here to continue solving for y? What's with the y we need to get rid of? Jordan, go ahead.
Divide by the negative.
We'll do that eventually, right? We'll divide by the number first, but let's get rid of this 147/16 first. So we'll subtract both sides by the 147/16. So we'll have negative 1/16 y equals t minus 3 squared minus 147/16. All right, we subtracted this over to this side. And now, Jordan, what should we do to both sides?
Divide by the negative.
Yeah, so divide by negative 1/16, or we can multiply both sides by just negative 16, right? We can eliminate it by multiplying by the reciprocal of this. So we'll get y equals, and then this times negative 16 will be negative 16 t minus 3 squared, and then negative 16 times this is going to be a positive 147, right? Because the 16s will cancel. So we multiply both sides by negative 16. And it works out to be this. So, what's the vertex of this quadratic? 3, 147. And what is the maximum height? 147. There's our answer. Okay, feet. All right. So it's a little bit funky. I know we're doing like work with like y over here and stuff like that, but you know, you eventually get the y back by itself, and then you get your vertex form. Okay. So pretty tricky stuff. Questions on any of that? All right, I want to get you guys time to start working on this here. So in the book, and I will post this in just 2 seconds here. Okay. Starting on page 288, so this is 4.7. Page 288, again, we're in the green book. Numbers 6, 10, 16, 21, 24, 27, 30. 41. And then I gave you one kind of the baseball problem there, number 39. So I'll put that one out, separate it out special. I put it out of order of the rest of those because you can do that one last, okay? I'd encourage you to do that one last. All right. Finish this video here. Yeah, go ahead.